Alright guys, so welcome back. In this video we're going to talk about testing claim regarding proportion. Starting out by looking at the test statistics. How would you find the test statistics given certain data? And then we move on discussing the type of hypothesis test. We have three different tests. And then we're going to look at the example in this lesson. I'm going to go over the entire process of what we're supposed to do in a hypothesis testing, at least in our class. So that's gonna be the last video for this lesson. In the last lesson 8.1, we kind of went over the basic of hypothesis testings. An example we did in 8.1 was mainly just how will we determine the alternative hypothesis, how do we write the claim from the example. So that's the beginning part of the hypothesis testings. In 8.2 we're going to get into the body part, which is the second part, mainly do a little more math and uses what we learned so far in chapter 6, normal distributions, and find the z-score, p-value, all that stuff in this lesson. And then we finish up this lesson with an example of hypothesis testing. Okay, so let's start with just this first example here, finding the test statistics. So for proportion, the test statistics formula for proportion. So we're going to say the test statistics for proportion is going to be equal to this formula. We're going to take the sample proportion minus the claim value p, and then divide that by p times q over n. So usually this here is the claim value of the population parameter. Okay, and this here is the standard deviation of the sample distribution of sample proportion. Okay, so that's the formula. So let's read this problem here. It said that claim most adults would erase all of their personal information online if they could. A software firm survey of 551 randomly selected adults showed that 63% of them would erase all of their personal information online if they could. Find the value of the test statistics. Okay, so we're given that most. So here's the claim. Right, so I'm gonna go ahead and write that claim as a symbolic statement, so that way it's clear. So I'm gonna say claim. Okay, P. So it said P is so most adults. So usually when we use the phrase most adults, we refer to more than majority. So more majority usually refer to more than 50%. So P greater than 0.5 means the proportion, the percent of adults that would erase their personal information online if they could. And that's the proportion we're looking at here. So that's the claim. So from there, using 8.1 concept, we can say that the null would be just p equal to 0.5, and then the alternative is going to be p greater than 0.5. Okay, so from there we're going to find the test statistics. Okay, that's what we asked to find. Okay, the test statistics is going to be p hat minus p over square root of p times q over n. Right, so from the given problem here, p hat is going to be equal to 0.63. That's what the study show. Okay, n is going to be 551. P is the population claim value, which is 50%. Okay, that comes from the null. Okay, so let's go ahead and plug those values in here, and then use a calculator to get what the test statistic would be. Okay, so crunch those numbers in your calculator. That should give us the test statistics. So if we want to, we can call this test statistics. This is going to be a z-score. Let's call this z-star here. And then that's going to come out to be 6.1 test statistics. So what this really is saying here, guys, if the claim said that the proportion of adults would erase their personal information online is more than 50%, we'll say, okay, well, let's look at, suppose that, the proportion is 50%. Let's look at the distribution of all sample proportion, where the mu of p hat is 0.5. Suppose that there's no difference there. Let's look at a sample of 551 random adults. If the proportion of adults will raise their personal information is 50%, then we'll expect from a sample of 551 that sample p hat, that percentage p hat will be close to 50%. It turns out that that test statistic, that sample p hat there, okay, this sample p hat there is, so to describe that, this here is p hat is 6.1 standard deviation below the claim value, the value we assume here, the claim value. And without really understanding where, much about hypothesis testing, we know that from the previous chapter, according to empirical rule, about 95% of the value data, their values are within 2 standard deviations. So if this sample p hat is more than 2.2 standard deviation, this is way significantly low, the claim value. So chances are, this right here is not true. Okay, because our sample data does not support that. Okay, but in this problem here, we only asked to find the test statistics. So from this example here, what I want you guys to take for that is, what is the formula used to compute the test statistics, and test statistic. Okay, and what does the test statistic stand for? When we get to do hypothesis testing regarding the mean, the formula will be different. It's not going to be p hat, but it will be x bar. Okay. All right, so let's move on to next example. Claim. Okay, the mean pulse rate in beats per minute of adults male is equal to 69 beat per minute. So this is the claim. They're saying that the mean pulse rate. Okay, so we say claim. Write that in symbolic form. Mu is the mean pulse rate of adult males. It's equal to 69 beat per minute, and we look at sample. Random sample of 126 adult males, and then the x bar sample means is 70.4, the standard deviation is 10.8 beat per minute, and we want to see how close is this sample means to the claim value. Okay, so using 8.1, if that's the claim, then the null would be always equal to the claim value, and then the alternative is going to be opposite to the null hypothesis. In this case, to show that this null is not true, or to reach a different hypothesis, we just have to look at the sample data. Is it more than significantly the 69, or is it significantly below 69 beat per minute? So the alternative is going to be not equal to 69. Okay, let's go ahead and write down what we're given here. So we're given n is 126. We're given x bar is 70.4 beat per minute. And then we're given S, the sample standard deviation is 10.8 BPM. Okay. Here is the formula for the test statistics regarding the mean. So test statistics. Okay. And we're gonna call this T star. Okay. All right. Is going to equal to x bar minus the claim value divided by the sample standard deviation over square root n. Very similar to what we're doing in the past chapter 7 confidence interval. So let's go ahead and plug those values in. 70.4 minus 69, and s is 10.8 divided by the square root of n is 126. Let's go ahead and see what that value turned out to be. If you do it correctly, you should get 1.455. So what this saying that the test statistic is 1.455. In other words, if the assumption say that suppose the mean pulse rate for adult males is 69 beat per minute, if that's the case, from a random sample of 126 adult males, we will expect that the average mean pulse rate will be pretty close to 69 beat per minute. Well, we find out a random sample, and then the x bar of that, or the sample mean pulse rate of that is 1.45 below 1.45 standard deviation below the claim value. So is this significant below, or this is above? If this significantly high is 69 the claim value, and then the sample value is 70.4. Is that pretty close? Is it is show that this is true here, you know, I would say so. It's only 1.4 standard deviations. We'll find out more once we get to the next couple example. How do we determine, you know, where the cutoff point is? But that is the test statistics there. Okay, for this sample. All right. I'm gonna go ahead and pause in this video, and I'll go over the next thing in the next video.